What we're going to do now is just show you a little bit about what goes on inside an engine, how carbon forms, and what we can do to get rid of it. Okay? We're going to demonstrate part number 208, which is 44K. Phenomenal product. There are many little parts to this demonstration, but this is the demo that I normally do in the shop with it. Just strictly to demonstrate while you're doing a 9210 demonstration how the 44K part works through the tank. Okay. What I'm going to do is I'm going to take a sample of gasoline that was fresh this morning. I can attest to that. This is a sample of gasoline I got from the ground this morning. What I'm going to do is put a sample in here, and then we're going to oxidize it rapidly. Until about 1974, only about 11% of a barrel of oil was used to make gasoline. The rest of it went into propanes and butanes, you know, cooking gases at that time. Okay, it also was used for tar for the roads, diesel fuel, all that type of thing. In 1974, we had the first Arab oil embargo. Okay, I don't remember about you, but I was in New York City at the time, and we had to line up almost all day to get a full tank of gas for your car, if you could get it. Okay, so what they did after that was they blended the gasoline, supposedly for our benefit. So instead of using 11 to 15% of a barrel of oil, they went to 50% of a barrel of oil, making gasoline from it. So what they did was they took some of the light stuff, the propanes and butanes, mixed them with the heavier stuff like tar or bitumen and diesel fuel, mixed them together and held them together with olefins and diolefins. If you remember, if you leave your gas tank of your, let's say your lawnmower, out over the winter time, okay, with no fuel stabilizer in it, what happens to that fuel in the tank? It goes slimy, okay, gets a varnish that drops out of it. If that stuff still goes through your system, you're going to end up with just a ton of deposits. I'm going to speed that process up a little bit, okay? This is a sample of fuel that I pulled this morning. This is an oxidizing agent. It is actually concentrated sulfuric acid, okay? It depends on where you are. Sometimes you'll need 2 drips, sometimes you'll need 3 drips. There's 1, 2, 3. It's powerful stuff, so be careful. Okay, now we're going to mix it up, and we're going to break this gas down rather rapidly. Okay, give me a couple of seconds, and then I'll start to roll it, and what happens is the olefins and diolefins start to drop out in the fluid. See that yellow slime on the test tube? That's olefins and diolefins and tar that used to go on the road that is now coming out into your fuel system. I don't know if you can pick up this stuff inside here. Can you see that okay? Okay. Can you see that in the audience okay? Yes. Okay. This is olefins and diolefins running out of here. So I'm going to pour this off now, and you'll see that if I heat this up carefully, the operative word is carefully, and make sure you pour off the gasoline first. Don't heat it with the gasoline in there. Okay? I've done that. Yes, olefins are used, olefins and diolefins. The other usage for them is in making carpeting. Okay, so you use it to make carpeting. When you go in any carpeting store, they say, oh, this contains diolefins. Okay, if you've ever seen a house fire and looked at the carpeting on the ground, it is a lump of carbon sitting there. It is olefins and diolefins which you have in your gasoline. Look at that tube. Unbelievable the amount we get out of this. What I'm going to do is just heat it just gently at the top. Not too heavy, just enough. Now we've got carbon. That is exactly the way that carbon forms inside your engine. Heat, and these olefins and diolefins that drop out, and you just heat it up, it causes carbon to form. If you leave the carbon on top of a piston, as you turn the engine off, your engine does a heat soak. More gasoline sits on it, it gets superheated because there's no coolant circulating, and what happens? You get more carbon, and it goes in a curve like that. A little bit of carbon to start with, over a period of 20,000 miles, you're going to change that compression ratio substantially on a car, probably by about 6 octanes. Okay? So, now we got carbon. Here's the way we clean it up, right? According to the corporations, we take some gasoline. This cleans up the deposits the others leave behind. Or give me 6 tankfuls, I'll clean up your engine for you. Here we go. Gasoline. You want to make sure this is cooled off in time before you pour hot gasoline in there. It tends to have a funny habit of catching on fire if you don't. Okay, I'm going to do it very gently first because I don't want to cause too many problems. But there you go. This stuff is going to break down even quicker. Look at the slime that's forming inside this test tube now. This is the new gasoline that's supposed to be cleaning it up. The residue that is left on top of that piston is now causing the new gasoline to break down and cause even more deposits. The way to get rid of it is to add some 44K. This is not cheap. 1 can of 44K will reduce the octane requirement of your engine by 6 octanes. That was according to the examining board when they first tested it. Here we go. I'll put a little bit in. Naturally, I want to speed up the process a little bit, but 1 can of 44K will treat up to 20 gallons of fuel, gasoline or diesel. When you're adding detergency and cleaning agents to it, let's take a look at that test tube now. Okay? Look at that test tube, how clean it is. We've got a little bit of carbon left. But look at the fluid itself. Everything has been dissolved down into the fluid. So now this can go out of the tailpipe and burn. Can you see that clearly? Okay. Now what we're going to do is show you what happens to the carbon. Inside a combustion chamber, there is a lot more pressure developed in there. I can't really do that by just washing a bit of fluid on carbon because it's very hard to get rid of it. So all I'm going to do is show you how soft that product is now, the carbon. The polyetheramines and things that are in this chemistry will just dissolve that down to just a very fine powder, and it just dissipates completely. It will now be carried down through the system and carried out of your tailpipe during the process of combustion. Carbon is a very, very hard composition. You can't really break down carbon itself. What we're doing is we're attacking the waxes and varnishes that hold the carbon together. So we break it down into a powder form. And then the powder is carried out by the 44K as it goes down through the system. 44K does not burn completely. It will carry it out through the system, as opposed to some of the others which are alcohol, okay, and will combust and burn before they even do anything. That's what we're trying to achieve. We're going to try and carry this out through the system. Let me just show you one last little thing here. This is a valve. Okay, it's got plenty of carbon on top of it. Okay, lots and lots of carbon. This would change the way your car runs just with this little bit of carbon. It's very, very hard carbon. We had problems getting this clean before. This is what I do it. This stuff has already cleaned up a load of sludge that was left behind before. Let's see how strong it is. Let me just put a cloth here. Okay, I'm going to pour it on the carbon. Just let it soak for a second. Okay, it'll start to drip and then you get a lot of carbon coming out. Now if we wipe it, you can see the carbon actually comes off on my fingers. It just takes a few seconds and it starts to soften it right up. Look at that. That's all you got to do. It softens that carbon right up. And we're going to start rubbing it off with just that little drop of stuff. If you use 44K and you use it around town, if you haven't got 44K in there, you build deposits rapidly by turning the engine on and off. You do a heat soak and it breaks the gasoline down quickly, as we showed. If you have 44K in there, what's going to happen is the 44K with gasoline is going to soak into the carbon and soften it up more. So when you restart it, you'll get rid of more deposits. 1 can in 20 gallons is the perfect ratio. If you've got a small car that only has 11 or 12 gallon tank, it's not a problem because that fuel goes through much, much slower. But 1 gallon, use a full tank of gas. Up to 20 gallons is the way to do it. And the same can be said, exactly the same demonstration applies to diesel fuel. If you put diesel fuel in a test tube, a couple of drips of acid in it, you'll get just the same deposits out. 44K will clean it back up again. 44K is magic. It is absolute gold, okay? Liquid gold. Unfortunately, somebody else took that name. What I need to do is just follow up with a little summation here as far as how does 44K work? What does it do to your engine? Okay, what's it going to do when you put 44K inside your engine? Why is it different from other people's products? Okay, first of all, let me give you a little bit of understanding about what happens inside an engine. What is gasoline and what is octane? Octane and heptanes are all refined from gasoline. Okay, heptanes are easier to refine than octanes are. Heptanes are 7 molecule strands. Octanes are 8. Okay, octanes are better combustion, better power, okay, than heptanes. When you get 87 octane gasoline, it is 87 parts octane and 13 parts heptane. Similarly, when you get 91 octane gasoline, it is 91 parts octane and 9 parts heptane. Okay, that's how it works. Heptane is much cheaper and much more explosive. Okay, it is not as easy to stop it from self-combusting as heptanes are. So what happens is you need a car that you need 87 octane to make your car run the way it should do when you first bought it. No deposits, no nothing. Okay, 87 octane is what is needed just to give you the best combustion out of that gasoline, the best power, without the possibilities of run-on or pre-combustion. Okay, what happens when you build deposits on top of a piston? Okay, what happens is you're now changing the compression ratio of that car. So the compression ratio is rising. If you have a low octane gasoline in there, it's actually going to explode too quickly before it's supposed to. So when it happens like that, what happens is the computer senses that knock, okay? And that's why you've got a knock sensor inside your engine. It will sense that knock, which is coming too early, and then what happens is the computer retards the timing. When it retards the timing on your engine, it takes away the power from your engine. So yes, you've got the same gasoline you're putting into it, but you're getting less power out of it. That's caused by the carbon on top of the piston. Over the period of 20,000 miles, you're going to change that compression ratio enough where you will need 6 octanes more from your fuel to make it run the same way as it did when you first bought it. 6 octanes. What is the difference in price at the pump to go from regular unleaded gasoline to premium gasoline? Around the country, the average is 20 cents per gallon. That is 20 cents per gallon that you've wasted. You've just thrown it away, okay? That is to make your car run the same way as it did when you first bought it. By cleaning up the engine with a can of 44K, and according to Chevron, when they first tested 44K, if you use 1 can of this in up to 20 gallons of fuel, you will lower the compression ratio enough where your vehicle requires 6 octanes less than it did previously when it was dirty. 6 octanes, 20 cents per gallon you are now saving by using 1 can of this. Okay? Over a 10,000 mile period, that would actually comes out to about a penny per mile. The average vehicle does about 20 miles per gallon. Over a 10,000 mile period, at 1 penny per mile, that comes out to $100. Okay? So you've now saved your customer $100 in their fuel bill by using 1 can of this approximately every 10,000 miles. If a customer says they get more performance out of a 91 octane fuel than they do out of an 87 fuel, then yes, you've got a pretty good idea that they've got some deposits that built up on top of the piston because it stops the knock, everything else that goes on with it. The computer is not sensing a knock, so it can advance the timing back up again. Okay, brings back the power. Advancing the timing usually brings back quite a bit of power. But the ideal way to do it is to clean it. It is much cheaper and much more effective to clean it. You will bring back the advancement on the computer again. You'll bring back the power, and it will save you about $100 on your fuel bill over a 10,000 mile period. Makes sense to me. Much better performance, much more economical for the customer. Can you argue with that?